This lesson is for day 5 notes, and we're going to be doing a brand new skill, brand new topic for you guys, which is called completing the square. What completing the square allows us to do, it's an algebraic technique that allows us to convert a quadratic, which is in standard form, into vertex form so that we can graph it really easily. And then we're going to work on graphing the quadratic in vertex form, but that's not going to come until tomorrow. Alright, so the first thing I want to do is make sure you understand the relationship between a perfect square trinomial and what its factored form looks like. So here I have this perfect square trinomial, and all that means is that something, it's called a perfect square because something squared gives me that trinomial. So if I were to FOIL this out and expand that, I would get x squared plus 8x plus 16. So by factoring this, I come up with this. By foiling this, I come up with that. Okay, that's the relationship between a perfect square trinomial and its factored form. Now, what we're going to do is real quick complete the rest of this table. So this next example here, when I see that negative 8x here and a positive 16, that means that its factored form was x minus 4 squared. Okay, x minus 3 squared would give me x squared minus 6x plus 9. And very quickly I can do that because I know that if I double the middle term, that would be negative 6x, and then I square that term, I get a positive 9. So that's how you can quickly FOIL. And if I want to go backwards here, I would take that and cut it in half to get x minus 15 squared. Okay, so you can double check that 15 squared does give you 225, but this is why you end up with x minus 15. All right, now, without showing you what the perfect square actually is, I want to create a perfect square trinomial. So this is actually the skill that's brand new for you here. This is actually called completing the square. So we're going to go through a longer process for this, but basically, if you don't understand these 3 questions that I go over, the rest of this lesson is going to be quite tough for you. So you might have to replay this section maybe once, maybe twice, just in order to get these 3 questions down. So what we're going to do is find a constant that's going to make this a perfect square trinomial. So I want 3 terms, just like this one is a perfect square trinomial. I want to turn that into a perfect square trinomial. So remember, we cut this number in half to get this number here. Okay, this number is that number squared. That's the number 4 squared. So what I'm going to do here is cut this in half and then square it. So I would get the number 11, negative 11, if I cut 22 in half, right? So basically all I'm doing is negative 22 divided by 2. I get negative 11. And then I'm going to take that number, negative 11, and then I'm going to square it to get 121. So this constant would be 121. This would then factor into x minus 11 squared. Okay, so this is how you can relate the 2 of them together. I'm not asking you to find the factored form, I'm just asking you to find the constant here. Now in this next problem, this is a little bit trickier. None of these problems in this table really reflect this type of question here, but basically in this problem, if I just cut this number in half and then square it, it's going to be off by a certain factor. So what I want to do here first is actually take out the 9, because I noticed that these are this is the GCF between 9x squared and negative 3x, or it's a factor I should say, but I'm going to take that 9 out, and I have x squared minus 4x plus some constant. Okay, now it's a lot easier for me to find, first of all, this constant, because again I just cut this number in half. So I take negative 4 divided by 2 and I get negative 2. Now I'm going to take negative 2 and I'm going to square that to get a positive 4. Okay, now the original number though that's going to go inside this is not a positive 4. It's actually going to be 9 times 4. Remember, we factored out that 9, so it's actually a 36 that's going to go here. So this would be a perfect square trinomial, and that perfect square would factor into 3x minus 6 squared. Okay, this is this trinomial here factored here. Alright, the last one I think is tougher only because you have fractions, and we will be seeing lots of fractions in this section, in this unit. So from here on out, make sure you're very comfortable with doing a problem like this. So this is x squared minus 4/10, right? I'm going to rewrite 4/10 as 2/5. 4/10 and 2/5 are equivalent, plus a certain number, a constant that we're going to try to find. Again, we're going to do the same process. We're going to cut that number in half. When I cut -2/5 in half, in other words, I'm dividing it by 2, that is the same as multiplying by its reciprocal. So really I have the fraction -1/5, because these are going to cancel and I'm left with -1/5. Now I take that -1/5, remember the second part is to square that number, and I'm left with a positive 1/25. So this original number here in that constant would have been a positive 1/25, and I can rewrite that if I want to in decimal form. It's 0.04, but you don't have to do that either. But that's the constant that you would add. So this is just the idea of finding that constant term here, which is the skill that you're going to practice over and over again when you're completing the square. Now this trinomial, this term here, this 3 term, which is why it's called a trinomial, this quadratic here, is a perfect square because it would factor into x minus 1/5 squared. Okay, x minus 1/5 squared. That 1/5 should be familiar because that was the number that we cut in half, right? Just like over here in this first example, that -11, it came from cutting that number first in half. All right, so keep that in mind as we work through the rest of the lesson. Okay, so you might be asking yourself, why are we doing this? Well, a lot of times when you're given a quadratic, it's not going to be in a form that's very easy for you to graph, vertex form. It's usually going to be given to you in standard form, and we're going to have to complete the square in order to change it into this form. This form is much, much, much easier for us to graph, and we'll talk about how to graph that tomorrow. But basically, we're going to switch from this form, standard form, and convert to vertex form. That's what this whole lesson is all about. So I have this first example here. Here is the quadratic that I'm given, and I'm asked to graph this. Well, right away I see that it's in standard form. Okay, I have an A term, a B term, and a C term, but I want to put it in vertex form, because in vertex form I can quickly identify what the vertex is. It's going to be HK, the opposites, okay, what's in parentheses here and what's on the other side with the Y, and from there I can graph using stretch and shrinks and so on. So basically we have these steps here in order to complete the square. I actually have it on the back side too, but make sure that you are very comfortable with each and every single one of these steps, and you're going to see that problem, or the step 3, is very similar to what we were already working on. Okay, so the first thing when we complete the square is to move the constant. This is the constant, this is the C term. We're going to move that constant to the side with the Y. So I'm going to subtract 1 here, and I now rewrite that as y minus 1 equals 4x squared minus 8x. So this is step 1 completed. Okay, we got step 1 completed. Now step 2 says to factor out the quadratic coefficient. A coefficient is just the number in front of a term, a variable term, and in this case we're looking at the quadratic coefficient. This is the quadratic coefficient. It's the term in front of the quadratic, the squared term, and I want to factor out just the 4. I don't factor out a GCF, and this is what most people do in mistake. They take out 4x here, because they think, oh, 4x squared and 8x. That's not the skill that we're working on here. We're just going to factor out the coefficient. So we have y minus 1 equals 4 times x squared minus 2x. Okay, so this is step 2 completed. Now, step 3 says to take half of your linear coefficient and square it. This is the linear coefficient. Okay, this is the quadratic coefficient. This is the linear coefficient. So I'm going to take half of -2, which is -1, and then I'm going to square -1. So that's how I'm completing the square, just like we did in those above problems, where I took that number, I cut it in half, and I squared it. It's the same skill here. And this time we're going to add that to the equation. So I have x squared minus 2x plus 1. I hope you've noticed that all these constants are always positive because we are squaring. Either a negative or positive will always result in a positive, so you should have always a positive sign here. So I'm adding 1 because this is equal to 1. So I add that here. Now I have to make sure that I add this number to the opposite side because I need to make sure that I balance my equation. I can't just add, 2 or 5 or whatever number to one side of an equation. I always have to make sure that I balance it on the other side. So where I have y minus 1 is not just y minus 1 anymore. And it's not just adding 1. If I only add 1, I'm not taking into account the fact that I'm multiplying all of these things on the inside here by a factor of 4. So I really am adding 4 times 1 to the other side. So I add 4 to the other side to balance the fact that I just added a 1 times 4 on the right-hand side. Okay, this is called balancing the equation. So that was step 3. Okay, step 3 is completed. Now the last step is to factor the quantity in your parentheses. Okay, remember above, this leftover term here can be factored, and it's going to just be factored into the number that you cut in half. Okay, so this is on the left-hand side. I'm just simplifying here. That's all I'm doing here is -1 plus 4. But on the right-hand side, I now have a 4 times x minus 1 squared. I don't even have to think about how to factor this. Some of you might do extra work here and try to figure out how to factor this, but remember, you cut a number in half and then you squared it. So that original number here has to be what you put in here in terms of its factored form. Okay, so now we have this in vertex form. Okay, so this is the goal, is to put it into this form here, and we're going to label our vertex. So our vertex is the opposite of the sign inside for the x value here, so it would be a +1. That's our, remember, hk is the opposite of what's inside here, and our k value, the y coordinate, is going to be -3. It's the opposite of 3. So that's problem number 1, the first example in completing the square. Don't worry, we're gonna do a lot more because I'm guessing that this was probably kind of confusing for you. Make sure you replay stuff like I said to make sure that you really understand this concept. All right, now problem 2, or I guess practice number 1 here. I'm going to do this one with you, and I'm going to just look through these steps here to make sure I'm checking them off, and as I go, you're just going to see me check each one of these off, okay? So the first thing I'm going to do is move that constant. So I have y minus 29 equals 4x squared minus 24x. So I've done step 1. Step 2 says to factor out the quadratic coefficient. The quadratic coefficient here is a 4. So I have y minus 29 equals 4 times x squared minus 6x. So step 2 is finished. Now step 3 says to take half of my linear coefficient, half of 6. So I'm going to, off to the side, I'm going to do that work. Half of 6 is -3. And then I'm going to square that number. So -3 squared gives me 9. I'm going to add that inside the parentheses, but I'm also going to make sure that I balance the equation. This is super important. This is why I've got this in bold and capital letters, because so many people forget to balance the equation here. So on the right-hand side, I have 4 times x squared minus 6x plus this new number, 9. Okay, I'm adding that to the right-hand side. On the left-hand side, I need to make sure, I like to leave a space actually when I'm writing this out, because you're going to have to balance this. You're going to have to put this 4 times 9 on the other hand side. So you have to balance it by actually multiplying it. You have a factor of 4 here out in front, so you're really adding 4 times 9 to the whole right side. So I'm going to balance that out by adding 36 on the other side. So now I'm just going to simplify. So I have y plus 7 equals 4 times, now this is now a perfect square. I completed the square. That's why it's called completing the square, because I completed it to make it a perfect square, and that perfect square is going to be x minus 3 squared. Remember, that's the term that you cut in half originally. That's what that term will always be. So x minus 3 squared. So now I have this in vertex form. That was my goal. And I'm always going to list the vertex, and that vertex is going to be 3, -7. So it's the opposite of this and the opposite of that. Okay, so I have this step taken care of as well. Okay, what I would like you guys to do is definitely pause and make sure that you try problems 2 and 3. Okay, I will probably, for a video check, take these directly from one of these 6 problems here. So I might work through the exact same problem that you're going to do on your own in a video check tomorrow, or I'm going to pick one of the ones that I've asked you to do on your own. So make sure you do know how to do all of these, that you check with a key to verify that you can do them. These 2 are sort of easy, that's why I'm leaving those 2 for you to do on your own. I'm going to work on problem 4 with you because this one is definitely trickier. And then, sorry, I'm going to go out for a second, zoom out, but number 5 is similar to number 4. So I'm going to let you guys try number 5 on your own, And then number 6 here I'm going to do again with you. So this is going to be what I do in the video. And then number 7 you're going to try on your own. Okay, so I'm going to do out of these 6, 2 of them. Okay? Alright, now problem 4. We're going to follow our steps here. I don't have them off to the side, but you at least can see them on your own paper. The first thing I want to do is subtract the 3. So I have y minus 3 equals negative 1/4 x squared minus x. Now our first step after, or I guess our second step I should say, step 2, is to always factor out this quadratic term. So I have y minus 3 equals negative 1/4 times x squared minus, or actually this should be a plus, right? The sign is going to change here. And this is where it's really tricky because a lot of students do not know how to factor this properly, okay? It's no longer going to be a 1x here because you're factoring out 1/4, negative 1/4. Now, if it was a 2x squared minus 8x, let's say that was the original problem, and you factored out the 2, you can all very quickly tell me that that should be a negative 4 here. But what's the operation that you're doing in order to get 4? Well, you're taking negative 8 and you're dividing the 2 out to get you negative 4. That's the exact same thing that we're going to do here. We're going to take negative 1, that's the coefficient in front of that linear term, and divide negative 1/4. When I take negative 1 and I divide by negative 1/4, that is the same as multiplying by the reciprocal, negative 4 over 1. So that value should be a positive 4. Okay? This is why it's really confusing for students because they see this fraction and they think it should be small, but it's actually going to become a larger factor here. It should be 4x. So we have this after we factor out that quadratic. So this is why I did this one with you, is because I think it's difficult when you have to factor out a fraction. Alright, so replay that if you have any questions or if you're confused on that. Okay, from here on out, it's very, very similar to what we've been working on. It should be pretty basic from here on out. So next, I'm going to, for step 3, cut this number in half, cut the linear term in half, and I'm going to square it. So I'm going to leave myself some space here, because I know I need to balance that equation here. And I have the negative 1/4 times x squared plus 4x. This time when I cut 4 in half, I'm going to square 2 to get 4. So I have a 4 that I'm adding here. But remember, you're adding negative 1/4 times 4 to the left-hand side, which is going to give you negative 1. So now I'm going to simplify here. I have y minus 4 equals negative 1/4 times x plus 2 squared. Remember, it's that term that you cut in half. That's the number that you know for sure has to be that perfect square trinomial. Okay, and then our vertex is at negative 2, 4. And that's the end of that problem. Let's work on number 6 now. Okay, in number 6, I'm going to subtract the 3 to the other side. And I have y minus 3 equals x squared plus 11x. Now, that's step 1. So now step 2 says to factor out the lead coefficient. Well, the lead coefficient here happens to just be a 1. And if I factor out the 1, I'm still left with x squared plus 11x. So really, step 2 is, you don't have to work on that one at all. So we can skip ahead now to step 3. So step 3 says to cut this number in half and square it. So we have y minus 3, and I'm going to leave myself a little space, equals x squared plus, when I cut 11 in half, I get 11 halves. When I square 11 halves, I get 121 fourths. So I have x squared plus 11x plus this new number, 121 fourths. Now I'm going to add to the other side just 121 fourths because I don't have, I'm really just multiplying everything by 1. It's a factor of 1 times that to the other side. So since I don't have a number on the outside, I don't have to worry about balancing this one incorrectly because I'm just going to add that to the other side. Alright, now I'm going to add the fractions here and combine these two. Negative 3 plus 121 fourths is the same as negative 12 fourths plus 121 fourths. So I have y plus 109 fourths equals, and then on the right hand side, this is just x plus 11 halves squared. Remember, a lot of people get really confused here. They're like, how do you know how to factor that so fast? I don't have to even think about how to factor that because that term here is the term that I cut in half, 11 halves. It's always going to be that term every single time. People just, for some reason, don't listen to that part, and they try it the hard way. They try to factor this on their own, and they get really confused. So make sure you understand that this term and this new term are totally the same. They're completely related. That's the whole point of it, is you're creating your own perfect square. So you're using a value that's easy for you to find in the first place, because you're just cutting that middle term, this linear term, in half. Okay? So I just wanted to do a problem like this, one, to show you that it doesn't always have to be nice integer values for your vertex. So in this case, my vertex is negative 11 halves and negative 109 fourths. Okay, it's kind of an ugly vertex, but it's fine. As long as you're following your steps and doing everything correctly, you should be okay. All right, that's the end of the lesson. Go ahead and try the other problems, and make sure that you fill out the video feedback form and ask questions in class tomorrow, because we're going to get lots of practice with this stuff. Okay, good job. I'll see you tomorrow.